How do hackers steal passwords? Like when malware runs on your computer, it's looking for those stored and cached passwords that are saved to the file system. They're written to disk, but they are encrypted. So how do hackers decrypt them? Well, in this video, I want to talk a little bit about DPAPI, or the Data Protection API, that modern Windows uses to be able to store and easily retrieve encrypted passwords. And this is something that we can play with. So I'm inside of my Windows 11 virtual machine, and I'm going to open up a terminal, and I'll run this as an administrator. Just right-click to run as administrator, or Control-Shift-Enter. We'll have our user account control pop up. I'll just hit yes. I'll F11 to full screen that. And now let's say that I had my simple plain text password. I'm going to store this as a variable within PowerShell, so I'll have a $ prefix, and I'll set that equal to Hunter2, because that's a funny joke for those who get it. Say that's my password. But to work with this and a lot of the Windows functions, the internal like Win32 API calls, or to use the DPAPI or Data Protection API functions, we need to work with this in bytes. So I'll convert this type with the square braces, and I'll use system.text.encoding. And we'll say with 2 colons here, this should be UTF-8, where we can convert that to bytes with our plain text value passed in. Now we have all of the ASCII representations, the integer numbers 0 to 255. But now I want to encrypt this the same way that Windows and our operating system naturally would with any other password that's saved, like when you click, oh, save and store this password in your web browser, or you connect to another computer with the remote desktop protocol, or anything else that Windows might save. Oh, and we should actually make sure that our plain text variable is set to those bytes. So let me run that and store that in the variable there. Now let's start to work with some of those DPAPI functions. And the way that we can do that within PowerShell is actually by adding a type. At least I'm in PowerShell version 5. I know there's version 7 and there might be a little bit of an easier way to do this, but this is at least, I guess, compatible, backwards capability, whatever. So let's add a type to get a little bit more C# magic and more power for our PowerShell. Let's actually add in with the assembly name being system.security. I'll hit enter on that, and now we're ready to use some of the DPAPI or Data Protection API functions. The most important ones being protect and unprotect. This is essentially encrypt or decrypt. But there's an important thing to know with DPAPI in that it works with one of 2 scopes. Because the magic here is that this encryption is really tied to your computer or your user. And those are the 2 scopes, right? We could work with the local machine or the current user logged in. So let me define a scope, really. We need that to work with the protect or unprotect functions. And this is a long one, but I'll say system.security.cryptography.data protection scope. And then we'll colon that to be either, we can tab to autocomplete this, current user or local machine. I'll specify current user. Now we can encrypt our password, and we'll define this in a variable encrypted. We can just set that to be the system security cryptography protected data, and we'll colon for the protect function, which if we pass in our plain text and then null $ prefix for one other parameter, we can take a look at the documentation in just a sec, and then the scope. Now I can hit enter on this, but it's not going to return anything because that's all captured in our $ encrypted variable. Taking a look at it, it's obviously all again the 0 to 255 byte representation. If we really wanted to see it, we could try to look at how we had previously with the UTF-8 get bytes, whatever, but really in this case it's ASCII get string, trying to represent that as a plain text string. Obviously though, it's all nonsense because it's encrypted. This is the representation that your computer will store, but it's using a master key defined by DPAPI and its work that's again protected by your local user's password or some other machine-specific internal details. We have the convenience here, though, to be able to decrypt this. If I were to change this now to a decrypted variable, rather than using the protect function, let's use unprotect, given our encrypted value. If I return this, we can see we have decrypted just previously, but now let's try to get string on that and determine what will that actually reference. $sign prefix for that variable, hunter2, our original password. But with this small little showcase, I've sort of glossed over the master key that is part of the equation here, but that is stored on your file system. But we can actually go see that. If I hop over to our local app data directory, I'm using the environment variable here, so the PowerShell provider prefix $env:, that brings us to our local user's username app data roaming directory. And inside of this directory, there is a folder for Microsoft, and hopping in there, we should be able to find another directory called protect. And this is where you'll see everything pertinent to our master keys, but actually relating to a specific SID, or like security ID, given your user or any others on the system. If I change directory into that, I'll tab complete it so I don't have to type it all out. I know I have a long prompt here, but let me ls, and you won't see anything. Usually, because these are all hidden system files. If I ls tac force within PowerShell, we'll display some of those system hidden files, and you might be able to see those a bit better now. There are a lot, all defined by a GUID. These are all machine keys. If I try and cat one out, we should be able to actually just grab one here, but it is, of course, encrypted data. Not super helpful. At the very least, non-printable characters or raw bytes. These master keys that are stored locally can be decrypted with the password of your user, and then that can be used to decrypt all the DPAPI blobs like we just saw with our hunter2 password. So that is a 1,000-foot view of DPAPI, but I can't really talk about passwords on Windows without, of course, discussing Mimikatz. And we'll talk about some other tools. We'll showcase Sharp DPAPI, we'll talk about dploot, and some others, because I really want to answer that question: what are actual adversaries using to steal passwords on Windows? We'll get into all that in just a second, but while we're talking about passwords, let me tell you about the sponsor of today's video. Let's be honest, passwords are still a mess. Forgotten logins, weak credential reuse, reset tickets clogging up the help desk, it's a nightmare, and attackers know it. That's why I'm a fan of SpecOps software. They take password security from reactive to proactive. With their breached password protection, you're blocking over 4 billion compromised passwords, updated daily, from real-world leaks, live attacks, and even malware botnets. And it's not just password resets. SpecOps actively scans your Active Directory environment and flags compromised passwords the same day they show up in the wild. You can even build custom block lists, so users can't set passwords with your company name, project code names, or that one sports team that everyone's obsessed with in the office. And for the end users, they get dynamic feedback that helps them choose strong passwords that meet policy, without the guessing game. Fewer bad passwords, fewer help desk tickets. Throw in self-service password reset and built-in multi-factor authentication, and suddenly passwords aren't your weakest link anymore. They're just one more thing you've locked down smart. Check out SpecOps software and get started with my link below in the video description, jh.live/SpecOps. Huge thanks to SpecOps for sponsoring this video. All right, now we must show some love to Mimikatz. If you haven't heard of Mimikatz before, Benjamin Delpy, Gentle Kiwi, my goodness, this is the godfather of tracking down passwords on Windows. It is now well known to extract plain text passwords, hashes, pin codes, and Kerberos tickets from memory. Mimikatz can also perform pass the hash, pass the ticket, or build golden tickets, and it has a boatload of functionality. But I've gone ahead and downloaded it. You can grab a copy from the releases here, and let me say, this will light off your antivirus like crazy. This is going to be the most signatured, probably most detected thing ever, but I do have Windows Defender antivirus in this virtual machine completely nuked, obliterated, killed, and gonzo. So I've got Mimikatz here A-OK, and I can go ahead and run this, and I will run as administrator just so we have full privileges here to be able to play with it. And with that, let me go ahead and use the usual boilerplate to get this thing running smoothly. You can amp up to get all the privileges you need with privilege : debug. Now, they actually have a module. If you start to type in dpapi, you can use the 2 colons here and then prompt for a little bit of help or information on what other commands you might be able to run. Take a look at all you can do here. You can describe a dpapi blob, protect it or unprotect it with the API or a master key, protect data just as well, or even describe any of the master key files that we saw just previously when looking through our file system. I think one of the coolest things, and probably the most flashy one to showcase, is trying to extract passwords out of Google Chrome. Of course, you can get things like SSH agents, RDP saved passwords, or PowerShell credentials that might be stored in here. But let's try and play with the Chrome capability that will prefix with that very same dpapi and then Chrome. Now, this will say, hey, we actually need to fill in some info that is stored in where Google Chrome will cache a lot of the info. It is truncated here, so I'm just going to exit out of full screen momentarily and then move back in so I can see this, because we will provide a /in parameter, and we could use this to specify where Google Chrome has on the file system these stored and cached credentials, all encrypted with dpapi. Now, if we were to run this and pass in that argument, we will still need to actually provide a little bit more detail here. I'll try and hit enter just to see, but it's not going to see anything coming through because we need to provide the encrypted key that we could actually extract out of this file here. But I gotta be honest, we've showcased getting Chrome passwords before in another video, so just to, I don't know, do something unique and new for me, we can pull this out of Brave. I do like to use my Brave browser, and hey, it's really the same thing at the end of the day, but it's gonna end up being stored in a similar location. So let me get my terminal back open, and I'll open up another administrator PowerShell prompt here. We'll move into that local app data directory where all this going to end up being kind of cached. And I'll use the really environment variable one to reference that within PowerShell. And that should be in our local app data. So you can prefix local app data here. Now, we do have, rather than the Google folder that we'd like to move into, let's try to move into the Brave software folder. Moving into Brave software, inside of this directory, we have the Brave browser, which we can hop into that, and the user data, and all this structure is very, very similar to Chrome. In this case, the login data is what we'll be looking for. Actually, forgive me, for web browsers, the login data is what will be in that default directory for that user profile, but local state is where we can find the encrypted key that the operating system will use with that. So I actually want to go cat out the local state file here, and I want to convert this from JSON because there's obviously a lot of data in here, but if we actually pipe this to convert from -JSON, then we should be able to process and get all these as like PowerShell objects, and we can wrap that in parentheses to then extract out the OS crypt, I think that is, and the encrypted underscore key. And there is the special magic value that is what Mimikatz could use if we're looking at now strictly the Brave passwords and not just Chrome. We'll provide this as an argument to Mimikatz, and we need to change our path within Mimikatz just as well, because I want to be doing this now for Brave and not the Google Chrome. Let's do Brave software, and that subdirectory is brave-browser, then the user data default login data, but we'll supply our encrypted key as the colon here, and we'll paste in all of that base64 encoded data. I'll hit enter on this, and it tells us, hey, this encrypted key looks like it's protected with dpapi, which it is, but Mimikatz makes this super easy. We can just use -unprotect, and then it will carve this all out. It'll use the crypt unprotect data API function. It gets the AES key that it needs, but I don't have anything currently saved in my, save passwords as if I were using my web browser. So let me open up Brave and try to log in somewhere to get a password. Let's get to Brave. All right, here's like an example from W3 Schools in a registration form. Let me enter a password here. Let me see, can I register with that? Will Brave ask to save it? Yes, let's totally save that password. I know it'll save it to the password manager on this device. Now let's try to run the exact same dpapi command with Mimikatz, unprotecting the passwords, and now it's been able to carve that out. Obviously, hopping back over to Brave, if I try to go take a look at my passwords manager here, you can see W3 schools, but if it asks me to, hey, take a look at this, it's trying to make sure it's me, it's asking for my PIN. But dpapi, remember that's tied to my local account, which means it's protected by my local user password, which is just fancy pass inside of this virtual machine. You can see that, password, and I'll hit OK, and now it'll let me see it. Now this is the same for all like Chrome-based browsers. Google Chrome, Edge, Brave, of course. It all funnels down to dpapi when it's saving the passwords locally on Windows. Now, automated malware, of course, could track down that encrypted key, be able to extract and carve all this out, and you've got a lot of the same functionality that Mimikatz could offer, just as an example here. But Mimikatz, of course, is absolutely going to be caught by antivirus. So putting our hacker hat on, maybe it's not always the best option. So a lot of other smart people who've been digging through this, and I know this is a dated post, like looking back to 2018, but this is put together by Harmjoy or Will Schroeder over at SpecterOps. A lot of folks know him. Hey, that dude's a genius, absolute wizard. And he walks through the dpapi crash course. Well, he reviews a lot of the stuff that Gentle Kiwi put together in Mimikatz, along with a lot of other research that's been out and about. And he discusses how this could be used to track down different credentials, of course, Chrome as an example, and then a lot of different scenarios, how this might be used in a user context or maybe a local machine account when other users are logged in, etc. Otherwise, things with an Active Directory environment. And that is a whole nother can of worms here because that gets into backup keys and some of the representations that can be stored in. This is a ginormous post. I'm not going to dig through all of it by any means, but I'll link it in the video description so you can read a little bit more. At the end of the day, he put together Sharp dpapi. In this utility, Sharp dpapi is a C# port of some of the Mimikatz dpapi functionality. Benefit of being in C# is that this can be ran as a managed assembly and basically ran just pure play in memory. A lot of other cool things you can do here, maybe extracting the machine keys, extracting credentials, etc. If you're using a sweet Cobalt Strike beacon or like a Havoc Daemon or whatever implant with whatever C2 you might like, hey, you can use this just as easily. There's also another derivative specific with Sharp Chrome. And if you kind of wanted an easy opportunity with this, everything that's really part of the Ghost Pack or a lot of the sweet tooling put out amongst the SpecterOps folks, there is a Ghost Pack collection with the compiled binaries. Down here, remote control does have a lot of these already available for you, so you don't need to download the like Visual Studio solution or whatever. They'll just give you the executable files you can download and run right away. Another sweet tool that I wanted to call out was DP Loot. This is the dpapi looting remotely and locally in Python. So this, I think, is neat. It's a Python rewrite of Sharp dpapi, which was written in C#, that's put together by Harmjoy, which again is a port of dpapi capabilities for Mimikatz by Gentle Kiwi. But you get to do this in Python, so if you want to do that even from Linux, you can kind of do this with a little bit of remote capability. That is also accessible to you, and a cool one to be able to put in action here. But anyway, there is a question that I wanted to answer. How do hackers, how do threat actors, how do actual adversaries pull down and steal these passwords when they're hacking away at Windows? And I think one of the best ways to track down the real answer to that is by taking a look in MITRE ATT&CK. MITRE ATT&CK framework oftentimes categorizing different techniques, different TTPs, tactics, techniques, and procedures. But one of the techniques, oftentimes gaining credentials or extracting them from password stores, has a lot of sub-techniques, right? Getting credentials from web browsers or the Windows Credential Manager or password managers, etc. But then we could actually see what are different groups, maybe using different procedures to be able to extract things. So Agent Tesla, some of the threat actors there can steal FTP client and wireless profile passwords. APT33 has used publicly available tools like Lasagna, LAZAGNE, Lasagna. Lasagna is a post-exploitation open source tool used to recover stored passwords on a system, has modules for Windows, Linux, and OS X, but is mainly focused on Windows, and it is publicly available on GitHub. This includes some of the techniques, how they're actually cutting this up with different kind of sources and things available there, groups that use this software. And again, this is Leaf Miner, Wizard Spider, APT3, Scattered Spider. All right, gets a shout out. Oil Rig, Muddy Water, APT33, as we saw. But we could pull this thing down, right? It is available on GitHub. So can we just go get lasagna? I don't think I would have ever said that in a video. All right, I've got it downloaded and okay, Python, probably py.exe or PyInstaller binary built out in the Python programming language. Again, antivirus is hardcore disabled and nuked on my machine, but if I now try to run our lasagna tooling, what do we got here? Bang, bang. Oh, already decrypting all of the master keys, dumping my passwords and private keys. Whoopsies. All right, so this being in a virtual machine, not a lot of this is going to be super tactical. I don't think I need to redact or obscure any of these, hopefully. But this went ahead and pulled everything for my user. Looks like it was able to get LSA secrets, hash dump, of course, and then was ripping this all out. Wow. What else can this tool do? Ooh, run all modules, run browsers, chats, databases, games, Git, mails. This is kind of crazy. All right, hit me with the all, pretty please. What damage can you do? Oh boy. All right, there's nothing else in this virtual machine, but there's a new tool for your toolkit, lasagna, I guess. What are some of the others? Astaroth uses external software known as NetPass to recover passwords. What is NetPass? NetPass password recovery, Major Geeks. Oh, Nersoft. Probably nersoft.net. Yeah, I think that's explicitly mentioned for others. Darkgate uses Nersoft network password recovery or NetPass tools to steal stored RDP credentials. Stealer1 credential stealer uses stuff with FTP. CMD key on local victim machines. Another shout out for lasagna. And Nersoft, of course, is going to have tons of these like Mail Pass View, Web Pass View. Mimikatz, of course, gets its honor. I think Nersoft is certainly the big one. If you look at all utilities here, there are a ton of these password recovery utilities, and Web Browser Pass View, that's a bundle of Internet Explorer Pass View, Firefox, Google Chrome, and wireless keys are in here, Outlook, etc., etc. I have gotten into some trouble playing with the Nersoft tools. That is a funny story that might not be best for the internet. But if I download Web Browser Pass View, can I get anything here? We'll see my please subscribe password, right? Let me download Web Browser Pass View. Let's do it. All right, are we going to see anything else dangerous here in Web Browser Pass View? What do we got? Oh, Maldiv Academy. Oh, they got me, but they didn't have a password. Lol. W3 Schools. Yep, you can see my please subscribe in there. Nice. All right, others here. More Nersoft, more lasagna, and then other maybe bespoke info stealer stuff, kind of doing a custom thing. But now you know, it's all those things on the endpoint, on the file system, locally. When the malware runs, where malware runs, it's going to have that capability to be able to pull stuff out, because if it's going to be encrypted on disk, well, if it could reach anything else on disk, then it can carve it out. Look, obviously security is a cat and mouse game, and that is a very high level, quick crash course, not doing it justice, to cover DP API or the data protection API. And web browsers are doing neat things. You know, there's a lot of cool innovation from Chrome lately to try and, better protect cookies or cache credentials and things like that. And I do want to cover that in another video, but today's focus was a little bit more on passwords. And look, if passwords are still kind of a concern for you, I did want to tee this up, give some love to our sponsor here. And I hope you got to learn a little bit more of the tools that are out there, because really that's what it's all about. Awareness, education, and just knowing what is there against you. Thanks so much for watching this video. Please do all those YouTube algorithm things like, comment, subscribe. Please do give some love to our sponsors, link in the video description. And with that, I'll see you in the next video.